Today we are going to discuss central limit theorem for sampling distribution of means. If original population is normal, then the distribution of sample means will be normal regardless of the sample size. We can pick small size samples or large size samples. The distribution of sample means will be normal, and the mean of that distribution, called mu x bar, will be equal to mu, which is population mean, and the standard deviation of the sampling distribution of means, called standard error, will be equal to standard deviation of population divided by square root of n, where n is the sample size. Now, standard deviation of sampling distribution of means has a name, standard error. It's not an error or anything, it's just a name. So you can call it standard deviation of sampling distribution of means, or you can call it standard error. If original population is not normal, but we are picking large samples, larger than or equal to 30 size samples, then the distribution of sample means will be normal, even if original population is not normal. So central limit theorem is a very powerful statistical theorem. It helps us apply the statistical concepts to situations like normal probability calculations to situations, even when we don't know much about original population. So again, the distribution will have a mean equal to population mean and standard deviation equal to population standard deviation divided by square root of sample size. If original population is not normal and the sample size is less than 30, we cannot say anything about the shape of distribution of sample means. So central limit theorem is a powerful theorem. It says as the sample size increases, the distribution of sample means becomes more and more normal. So if we pick greater than or equal to size 30 sample, then the distribution of sample means will be normal regardless of distribution of original population. Let's see a few examples in action. The number of hours Yuba College students study per week has a mean of 18 hours and a standard deviation of 8 hours. A sample of 36 Yuba College students is selected. What is the mean and standard deviation of distribution of sample means? And what is the shape of distribution of sample means? Now, shape of distribution in this case, we know will be normal because the sample size is greater than or equal to 30. And the mean of that distribution, mu x bar, that is going to equal population mean, which is going to be 18. And sigma x bar, standard deviation of the distribution of sample means, sigma over square root of n, that would be equal to 8 divided by square root of 36. And that is 1.33. Second part of this problem, what is the probability that the sample mean of 36 students is greater than 21 hours? Okay, what is the probability that the sample mean of 36 students is greater than 21 hours? Now we're talking about picking a sample of size 36, and we want the mean of that sample, average of the study hours for the sample of size 36, we want that to be greater than 21 hours. So I'm going to transfer it to mathematical language. We want the sample mean to be greater than 21 hours. Now I'm going to go ahead and find the z-score and then find the area to the right of that z-score. Now we know the z-score formula is data value minus the mean divided by standard deviation. Now in this case, my data value is x bar. Mean will be the mean of distribution of sample means, and standard deviation will be standard deviation of distribution of sample means. And the mean of distribution of sample means is equal to mu, which is population mean. Standard deviation is equal to sigma over square root of n. So let's go ahead and find the z-score in this case. The sample mean was 18 hours. Oh, sorry, sample mean is 21, right? We want the sample mean to be 21 hours. So 21 minus the population mean divided by 8 over square root of 36. Let's plug it into the calculator. That turns out to be 2.25. So that's my z-score. And I'm going to go ahead and draw the distribution. I always like to draw the distribution. Z-score 2.25 is about here, and we want area to the right of it. Why to the right of it? Because of this greater than sign. And we already saw the problem said, what is the probability that the sample mean is greater than 21 hours? Okay, now I'm going to use the LibreText OER calculator to calculate the area to the right of this z-score. My z-score is 2.25. Keep in mind, in the LibreText calculator, I'm not going to change the mean and standard deviation to any other mean or standard deviation other than leaving the mean as 0 and standard deviation as 1. Because I'm standardizing the normal distribution. I'm working with the z-score now. So my problem in terms of z-score is what is the probability z being greater than 2.25? And in standard normal distribution, the mean is 0 and standard deviation is 1. So let's get to the calculator. Area being greater than probability, or the area for z greater than 2.25. 2.25 is the z-score, and the mean is 0. Standard deviation is 1. Calculate. So here's my probability. If I round it to 4 decimal places, it's 0.0122. So probability here is 0.0122. How do we interpret this if we were to think about it in terms of percentage? So there's 1.22% chances if we select a random sample of 36 students at Yuba College, then their sample mean of average study hours for the 36 students is greater than 21 hours. And based on the given information that the average study hours is 18 hours with a standard deviation of 8 hours. So we did use the central limit theorem in this case. We were not given anything about original population. We were not told if it's normal or not, but we were picking large enough samples. And as long as we are picking large enough samples, we can apply the central limit theorem. So we have used CLT here to find the probabilities. Central limit theorem applies here. Okay. Next part, could you find the probability of a sample mean being greater than 20 hours if the sample size was 12? Now in this case, if the sample size was 12, could we find the probability in that scenario? Not really, because we were not given that original population is normal. If that's not given and your sample size is smaller than 30, then we cannot, central limit theorem does not apply. No, because CLT does not apply. And central limit theorem applies only when our sample size is greater than 30, which we don't have in this case. So we couldn't find this probability if this was the scenario we were working with. We could do the previous problem because we were picking large enough sample. My sample size was 36. Let's see the next example. Suppose Yuba College students spend 120 minutes on social media every day with a standard deviation of 25 minutes. A researcher randomly selects a sample of 64 students. What is the distribution of sample means? Find its mean and standard deviation. So distribution of sample means will be normal. Why? Because the sample size is greater than or equal to 30. And what is the mean of that distribution? That is going to equal to the population mean, which is 120 minutes. And what is standard deviation of that distribution, or standard error? That will be sigma divided by square root of n, which is 25 divided by square root of 64. And that is 3.13. Okay, next part. What is the probability of the sample mean being less than 130 minutes? Okay, so what is the probability that the sample mean, x bar, being less than 130? Let's convert it to a z problem. Then we can find area to the left of that particular z-score. So to find the z-score, we need x bar minus mu sigma divided by square root of n. We're using the z-score formula. Sample mean here is 130. Population mean is 120. Sigma is 25. Square root of the sample size, we have 64 students that we picked. And that turns out to be 3.20. So we want to find area to the left of z-score 3.20. I know 3.20 is far on the right of my normal curve. And I don't want the area to the right. I'm actually interested in finding the green area to the left. That's what I'm interested in finding. Because, why? Because of this less than sign, and less than 130 minutes is the sample mean probability we're looking for. So we want the green area to the left of z-score 3.20. Again, one more time, when I get to the standard normal distribution, I will use the mean as 0 and standard deviation 1 because I'm working with the z-scores, okay? So go to the distribution. I'm going to refresh screen. We want area to the left of 3.20. Mean is 0, standard deviation is 1. Probability is what we're trying to calculate. Turns out to be 0.9993, which is kind of expected. We knew that there's a lot of area. The z-score 3.20 is on far right. So I have 0.9993. 0.9993 is the area or probability. So how do we interpret this? That means 99.93% chances that we randomly select a sample of size 64, and the average time on social media for the sample of 64 students is less than 130 minutes. Okay, another example. Suppose adults drink an average of 2 cups of coffee per day with a standard deviation of 1.5 cups. A random sample of 12 adults is selected. Find the probability of the sample mean being greater than 3 cups. So in this case, because my sample size is small, which is 12, right? And original population distribution is not given. Original population distribution is not given. I'm not being told that my original population is normal. Original population distribution is not given. If we were told original population is normal, we could work this out, but we don't have these two conditions met, so CLT does not apply, and we cannot find the probabilities. We cannot find the probabilities. Okay. In this case, it would be probability because they didn't ask me to find multiple probabilities. So let me correct that. But if it did have any other parts, it would have been the same scenario. We couldn't work it out. We couldn't find it. Next example. Number of cups of coffee adults drink in a day has normal distribution with a mean of 2 and a standard deviation of 1.5 cups. What is the probability of randomly selecting an adult who drinks more than 3 cups of coffee in a day? Okay, so we can find this probability because we're given that we have normal distribution for original population. Because I'm given the number of cups of coffee an adult drinks in a day has normal distribution. So probability of finding somebody who drinks more than 3 cups a day, let's go ahead and convert it to a Z problem. Find the Z-score. It's data value minus the mean divided by standard deviation. In this case, the data value whose Z-score we want to find is 3. The population mean is 2, standard deviation is 1.5. Now I want you to read this problem carefully and understand this. This is not a central limit theorem problem. It's actually a normal distribution problem because it's talking about probability of selecting one adult, not a sample. Selecting one adult, randomly selecting one adult, I should write. What is the probability of randomly selecting one adult who drinks more than 3 cups of coffee in a day? So we're selecting one adult, right? Not a sample. So that's the key word. Keep in mind, this is not a central limit theorem problem. You are using your old z-score formula here, which is the data value minus the mean divided by standard deviation. So that turns out to be 0.667. 0.667. Okay, 0.667. And do we want area to the left or area to the right of this z-score? Well, I can see there's greater than sign, and it did say more than 3 cups, so we want area to the right of it, 0.667. Again, I'm going to go to normal probability calculator. Again, keep in mind the mean is 0 and standard deviation is 1 because we are standardizing the normal distribution. We are working with the standard normal distribution. Okay, we got out of the normal distribution, but we changed our problem to standard normal distribution, which is z-scores. Mean is 0 and standard deviation is 1. So I want area to the right of 0.667 greater than 0.667, and the mean is 0 and standard deviation is 1. And let's see, it turns out to be 0.2524, which means there's about 25% chances of randomly selecting an adult who drinks more than 3 cups of coffee in a day. Putting it in context, 1 out of every 4 or 25 out of 100 people, if you randomly select, would drink more than 3 cups of coffee per day. This next part, what is the probability of randomly selecting a sample of size 12 with the sample mean greater than 3 cups per day? 3 cups of coffee per day. Now the sample size is small here, but because I'm given that original population is normal, I can still work this out because central limit theorem applies here. I'm given the original population is normally distributed. I'm going to write the sample mean being greater than 3. Let's go ahead and change this to the z-score problem. Z-score would be the data value minus population mean, which is 2, divided by population standard deviation divided by square root of 12. Now, when you're entering it in the calculator, be very, very cautious. Start with a fraction and then go to the denominator, enter another fraction in the denominator, and in the denominator fractions denominator, you want to enter a square root. Okay, so it should look exactly how it looks over here. If you don't enter it carefully, then it can mess it up. Your calculations can be messed up. So start with a fraction, then go to the denominator, enter another fraction, and the very bottommost box should have a square root on it. Okay, so this turns out to be 2.309. 2.309. Now I'm going to go ahead and draw and shade my normal distribution. 2.309 is here, and we want area to the right of it. How do I know area to the right? Again, it says greater than, more than, so there was a greater than here. Okay. Let's go to our normal probability calculator and find the area to the right of 2.309. 2.309, and we got a mean is 0, standard deviation is 1. Calculate. Probability, if I round it to 4 decimal places, it's 0.0105. 0.0105. 0.0105. Now you can notice that probability of randomly selecting one individual who drinks 3 cups a day or more than 3 cups of coffee in a day is way more or way higher than probability of randomly selecting a sample of 12 people and their average number of coffee cups they drink per day is more than 3. That probability is much smaller. So probability of finding a smaller with this characteristic is much small. Probability of finding a sample with this characteristic is much smaller than probability of finding one individual with this characteristic. Now to summarize, keep in mind when you're doing these problems, normal probability problems and the central limit theorem problems, they are worded very similar. So when you're selecting one individual, they are your regular normal probability problems. You're going to find the z-score using the formula data value minus the mean divided by standard deviation. When you're finding z-score for a sample of certain size, you will be using sample mean minus mu over sigma over square root of n. And if the sample size is greater than or equal to 30, we can central limit theorem applies. If sample size is less than 30, we must be given normal population. We must be given normal distribution for original population. Hopefully it makes sense. See you in the next video.